Right, well, a very good evening, everybody, and welcome to the Wits annual Wits Maths Awards. My name is Simon Gear, and my only real maths credentials is that I managed to produce a couple of mathematicians. My son has been an enthusiastic member of the Wits general universe as a high school student. He's come in and out of the various Wits training sessions over the years, and my daughter is following in his footsteps in that she loves maths and is very, very strongly involved with it and passionate about making sure that she's the first in the class, but has decided to spend more time playing cricket than playing Maths Olympiad, which is maybe a poor show on her side. I'm very, very honoured to be your MC tonight, and thank you very much to Jonathan and to Pravesh, who have put this all together. I must note that from a purely empirical study, it is quite clear that if you want to have very, very good hair through your postgrad studies, then studying maths is clearly the way to go. I studied biology and geography, and unfortunately have no hair to speak of whatsoever. But if you have a look at Jonathan and Pravesh, they clearly are doing very, very well indeed. Beyond that, my only real interaction with certainly senior high school maths over the last little while has been watching how my son has dealt with it. And something very, very particular struck me, that he often goes to the catch-up classes that are available in his high school. And that is very, very much something that is aimed at, I think, the kids who are generally struggling, the rugby boys who've been off on tour or something like that, and have missed something, and they come back. But he's made two very, very clear principles in his study of maths all the way through high school. And this is a kid who's getting 95% plus. One is that if he doesn't understand a proof, he works on it with his teacher until such time as he understands it. He can't just regurgitate it, he actually understands it. And the other one is that he does go to those catch-up classes. And one of the weirder experiences for him has been, he's very, very privileged to be in a top high school where maths is streamed, and he generally is only in classes where he's with people who are also 90% plus candidates. But he's made a point of, if he's slightly unsure of something, of going to those catch-up classes and sitting in on them. And I think that that's a very, very important lesson to anyone who is watching this today, particularly the younger students. It's not enough just to know a proof. It's not enough just to regurgitate it. You have to be able to understand it as well. And I think that's been a superb lesson that I've learned through my son. I'm not going to tell you what I got from maths in grade 12. It wasn't pretty. But in the meantime, I would like very, very much to introduce to you our first speaker of this evening, and that is our Dean of Science at Wits, Nithya Chetty, Prof. Nithya Chetty. He's got an illustrious CV. He's been the Vice President of the International Union for Pure and Applied Physics. He's twice been the recipient of the American Fulbright Fellowship. He's a former president of the SA Institute of Physics. And he was also part of the group executive for astronomy at the time, with the NRF, with the National Research Foundation, at the time that the NRF was overseeing the astronomy portfolio during the build phase of the Meerkat radio telescope. So that is a massive telescope that is down in the Karoo, and if nothing else, provided the fastest internet in the southern hemisphere to the teenagers of Carnarvon. And I'm sure that they are very, very happy with Prof. Chetty for that. In the meantime, I'd like to call on Prof. Chetty. Hopefully he'll be added to the show shortly. There he is. And Prof. Chetty, welcome, sir, and take it away.
Thank you. Thank you so much indeed, Simon. Colleagues, I'm really delighted to be here this evening, really, and the opportunity to say a few words on the occasion of the prize-giving ceremony for the Wits Maths competition. Thanks to Jonathan and to the entire team, the Wits Maths competition team, for your very kind invitation. So, of course, we would have preferred a face-to-face ceremony, but the circumstances brought about by the pandemic make this online engagement very necessary. I commend the organizers for ensuring that we had a successful competition this year, despite the many challenges. Now, the Wits Maths competition started a few years ago, 2018, and is relatively new, but has quickly established a reputation of success and impact, and it is growing from strength to strength with several thousand participants this year. As I understand it, the original idea was to develop the Maths Olympiad community in Gauteng, but very quickly news of the success reached all corners of South Africa, and we quickly received requests from outside the province. And the competition then now is open to all schools in South Africa. And this year was the first time that we had African countries join, including from Nigeria, Botswana, Rwanda, Liberia. And I'm really very keen to see this grow. I've got to say that. It's marvelous that we can do so. Oddly, of course, despite the hardships brought about by the COVID-19 pandemic, we have found newer and more effective ways to work and interact remotely across just about every boundary you can imagine. And it's become routine in many ways, in ways that we could never have imagined before. Now, mathematics is a purely intellectual pursuit. You don't need laboratory facilities and that sort of thing. And so very amenable to reaching out to students and communities through remote electronic means. And I do want to commend the organizers of the competition for making this accessible to such a wide body of learners from so many different backgrounds, not only within our own boundaries in South Africa, but also to the countries north of us. Now mathematics is clearly, in my mind, the most fundamental of disciplines. I don't think anybody's going to argue with that. And any successful university, such as Wits University, must have a successful mathematics program. Success, of course, means many different things in the Faculty of Science. But I can assure you that if we didn't have a successful mathematics foundation within the faculty, we would not have a successful Faculty of Science. So success really at the university level includes pursuit of excellence in research at the highest level, teaching and public engagement. And it's in this respect that I've got to say that I'm most impressed with the enormous efforts that have been taken by colleagues in the School of Mathematics and elsewhere, of course, elsewhere in the faculty, because this is a faculty endeavor, to make this competition the success that it is. This is academic citizenship of the highest order. And I do want to thank all colleagues for making this the success that it is. Now, mathematics is the basis for all scientific disciplines without question. Nobody's going to argue about that. Anybody who really is serious about science would have to agree. Without a solid foundation in mathematics, we will not develop quality scientists across all scientific disciplines. Critical scientific inquiry is the basis for knowledge creation and innovation, and ultimately for impact on people's lives. If we want to advance Africa significantly and improve the lives of all of our citizens, we must take science more seriously. And at the very heart of that pursuit is the goal to improve not simply the mathematical literacy of our population, but we need to produce mathematicians who contribute to the discipline at the highest international levels. The real challenge that we face as a South African nation, unfortunately, is our failing high school system in many parts of the country. Of course, there are many parts where mathematics is flourishing, and I commend teachers for putting the valiant attempts and efforts that are needed. But by and large, we have problems, and we've got to acknowledge that. But rather than simply sitting back and doing nothing or complaining incessantly, which is what I often hear, or expecting others to step up, or waiting long enough and hoping that somehow, somewhere, something miraculous is going to change this reality, I believe that it is the responsibility of each and every one of us to find ways to ensure that every learner is not lost behind. Every learner with potential must be given the opportunity to imagine a different possibility for the future. We must create opportunities for our learners to dream about a better life. And in my mind, exciting our learners about mathematics is that highest ideal. I think that mathematics is a beautiful subject. But more than beauty, it is a logical subject and a means for us to quantitatively understand the world around us, both real and imagined. By delving into the world of mathematics, we take those around us, especially our students and learners, into a world that lives in our minds, and yet it is real and tangible, with possibilities that are limitless. Who could have imagined that, based only on careful calculations, Yuri Gagarin, the Russian cosmonaut, 60 years ago this past April, hurtled himself through space at speeds reaching more than 400 kilometers per second? He became the very first human being to travel in gravity-free space and eventually, ultimately, landed successfully back again on planet Earth. It would have taken a tremendous amount of courage as well, I can assure you, but all based on mathematics. Since then, of course, so much has developed in space technology and astronomy, and you've heard of my involvement in astronomy here in South Africa, from the routine launching of communication satellites to living on the International Space Station. Mathematics has been very central to all of these endeavors. Colleagues, learners, students, there is no limit to what is possible if we can think mathematically. You're, of course, only limited by your imagination. And it is in this context that I want to say how important the Wits Maths competition is. To my mind, irrespective of where learners come from, they have the possibility to participate and compete with their peers and to test their mathematical skills and abilities. And success in the Wits Maths competition is an important initial step to reaching even greater heights in your young journey as a student. Ladies and gentlemen, I would like to congratulate the winners this evening. I know that there's several divisions and different rounds as well. I want to say that it is important that this be more than simply competition, but it should be an opportunity for learners and teachers to come together, to plan, to coach, to teach, and ultimately to learn and be inspired. There are many individuals who have worked tirelessly to make this a success. The regional coordinators were Matthews Masole from Botswana, Linda Emery from the Eastern Cape, Elsie Shumbi from the Free State and the Northern Cape, Graham Evans from KwaZulu-Natal, Andrew Obus from Liberia, Ibrahim Simsak from Limpopo, Daniel Akintoye from Nigeria, Jessica Veerbrecht from Rwanda, and Phil Labuschagne from the Western Cape. I thank you sincerely for all of your efforts. The question papers were set by an illustrious panel of Olympiad veterans, teachers, and academics. Notable participants this year were Margaret Archibald, Clint van Alten, Jara Fluxman, Andy Q, Nicholas Kroon, Khomotso Sebekwana, Clinton Smith, Jacques Duplessis, Evan Sneeman, Graham Evans, Hossein Akinci, Ronnie Martins, Sean Levitan, and of course, Betsy Young. Thank you, colleagues, for your magnificent work here. I also wish to acknowledge the computer engineering team who built the online system and consisting of Pravesh Ranchod, Carl Ginster, and Pinder Schlauer. They also organized the stream for this prize-giving function. The social media team consisted of Kumetsa Sebekwane and Sinovuya Demana. They did a great job, of course, in administering the Facebook and Instagram accounts. So colleagues, I'm proud to be associated, as Dean of Science, proud to be associated with the Wits Maths competition. The Faculty of Science does support the competition financially and in various other ways. We're delighted with the initial success over a brief while to be fair, but the future looks incredibly bright despite the challenges that have come about due to the COVID pandemic. We've been able to continue with the hard work, and long may this continue. Thank you all for listening in, and congratulations once again to all of the winners tonight. I thank you, Simon. All the way back to you then. Thanks.
And thank you very, very much for your kind words. I absolutely agree with you. I must also just apologize slightly for not being as well turned out as Prof. Chetty. I was fully intending to be in my home studio tonight, but load shedding has unfortunately put a spanner in those works. So I am in my my office at University of Pretoria, which is where I am currently employed, even though I am a proud Witsie to the very, very core of my being. One of the things that Prof said was the importance that maths plays in academia, and I cannot stress that enough. If you have strong mathematic ability and you take that through to postgrad level at a university, you can get involved in absolutely any research that you care to name. And my personal area of research is savanna ecology. So we're the guys who have a look at elephants and lions and all of those sort of exciting things. But often the guys who are good at doing that type of work are not great at maths. And if you are interested in a career in academia and have a maths ability to be able to actually follow that through and then parlay that into other research is phenomenal. And you will find you will be always welcome to put your name on very, very senior papers if you're willing to do the stats and the maths inherent in big research. You'll find that you'll be able to move your interest into areas across the globe and across the pantheon of areas of research. I'm very happy now to introduce the next speaker. In fact, it's not really going to be introduced by me. It is Prof. Robin Pimentel. He's joining us, I think, possibly from the University of Pennsylvania. But we are going to allow his acolyte, the chap that he is currently advising in, I think, possibly postdoc work, Jonathan Karev. Jonathan will be introducing Prof. Robin Pimentel.
Hi. So it's very happy to be introducing Professor Pimentel. He was my PhD advisor. He's he's Millennium Term Professor of Mathematics at the University of Pennsylvania. He's known for a lot of great work in probability and multivariate combinatorics, a course which at some point I had to take and was hard. There's a huge list of awards. For tonight's function, probably the most relevant is that he was a Putnam Fellow. The Putnam is another maths contest in US and Canadian universities for those who didn't get to go to Wits, but had to stay in North America. There's some great places there too. And he was also on the selling committee for it. Normally when I talk to people in mathematical sciences, I'll try to talk about mathematical puzzles. And usually they tell me to go away after not too long. Robin will not only immediately answer them, he'll usually give me 5 or 6 variations on the problem. I believe you're going to hear one of those tonight. And over to Professor Pimentel.
Okay, thank you, Jonathan. I assume, John, somebody say that you can hear me, and then I'll begin.
We can hear you. We can hear you.
Great. Okay. So, thanks for the wonderful introduction, and thank you to all of you who have been involved in sponsoring and putting on the Wits Math Competition. It's a great thing. These things reach a lot of people. They do a lot of good. They're fun. And as you'll see, it connects a little bit to some of the personal history I'm going to tell you. But let me say about this talk for a few minutes. I'll talk to you, and I want the subject of my talk is going to be crazy things we did when we were young. So, and you'll see how this connects very strongly to what we're all here for this evening. But so I'm not going to talk about the other crazy things like learning to jump off rooftops, hitchhiking all over the Bay Area. We did that. It was the 70s. But let me say the first crazy thing that we did is we all became math teachers. So these are a bunch of teenagers and people in their early 20s back in Berkeley, California in the 1970s. And so this was a time when the schooling system in many parts of the United States, and certainly around where I lived, was undergoing challenges and stretches. It was, changing from sort of one kind of entity to another, and there were serious problems with it. And so my parents, when I was just a kid, and my brother was even smaller, they decided to start an independent school. Very small at first, always struggling to survive, but they answered to no one, and they could do crazy things like hire teenagers who had no degrees. We were in college. Actually, I got hired before I was in college, and they could hire us to teach math to the upper grades in their school. So the upper grades were ages 10 to 14. So myself, my friend Jeff Walensky, Dan Bach, we became math teachers at a ripe young age. So and what's crazy about that is now you just can't do that. You have to have people properly certified and everything. So we weren't. But what they did instead is they hired consultants to run workshops to teach us how to be teachers, and in particular how to be math teachers. And these consultants were amazing. They taught us, each one maybe was in for a few hours at some point doing a workshop, doing some class observations, discussing it. They taught us an amazing amount of stuff. And down to the details of, look, when you asked that question, you were facing this way. The person you were answering was right in front of you. The rest of the class was not even involved. Why don't you go stand on the other side of the room? Have this conversation, draw the other students in, ask them what they think about it. It was all oriented towards making sure everyone was in the conversation. And this is how kids learned argumentation, right? Not just what's the right answer, but why the wrong answers are wrong, and just a deep understanding of everything. This was the goal, that everything we did in class would be completely understood. And so this is, I think, something that the previous speakers alluded to, right? How to go through your higher level mathematics and understand all the proofs. So we did this even with 10-year-olds, even 7, 8-year-olds. We weren't formally proving things, but kids needed to understand why. And so these consultants who trained us to teach, they taught us how to get kids to answer and think. They taught us how to trick kids into inventing math on their own. That was a lot of fun. They taught us how to track students' thinking and progress through solution to whatever problem you asked them to solve, and then to call on them in a discussion in sequence so that you could see, one idea building on another. And by the way, the curriculum was entirely problem-based. So it was the same arithmetic, algebra, and geometry in the end that everybody else learns in between ages 10 and 14, but it was a problem-based curriculum. I guess it wasn't exactly the same because we were free to go farther when we wanted. There's no reason that some of the concepts that you learn in a formal way in later years can't come into the classroom for students who are much younger as appropriate. So we did all that. And it was very rewarding, except of course on the days when it didn't work and the class flopped and it was the worst day ever. But I guess my point is that the experience of being trained to be a mathematics teacher at a young age is probably the most defining experience of my youth, probably even more than all of the math I did and the contests and so forth. So so this was a very supportive environment, and my parents ran the school, so they made the rules, and the rules were you don't have to get through a set amount of material. You just need to make sure that the students are engaged, active, thinking, and understand or try to understand everything. Not that we couldn't introduce some extra difficult puzzles that probably most of the students wouldn't solve and wouldn't understand. There was always the one more step. But whatever conversations we had in class, the rule was to try to understand. Didn't mean you'd get to the end, get to the answer, but you try to understand what the thinking was all the way along. And as I said, some lessons did turn out to be duds and students just didn't get it. And rather than wrap it up by saying, okay, this is how it goes, put it on the blackboard, we're done, we were trained to just abandon these. Say, oh, okay, well, you can wonder about this. We'll maybe come back to this next year. So another thing about me and my friends, we were also the first generation of hackers. So you young people, I don't know what you know of your prehistory in terms of availability of computers, but let me tell you, in the late 70s and early 80s, the first personal computers were just being produced, and we bought several of them. It was called the Commodore PET, and when you turned it on, it booted up, and it said 7167 bytes free. Okay, so this was a 7 kilobyte machine, and it could do amazing things. Coders had to be careful in those days to write non-wasteful code, but 7,000 bytes was enough to create video games and enough to have educational software. And my colleague Henry, who also worked for my parents' school, he was the first, I think the first person to write a serious math educational program on a personal computer. It was a Commodore PET. And this fed into the way we would teach, because we made a division between certain math skills you just have to learn and get good at. You know the drill. You have to know your multiplication tables. You have to know how to multiply polynomials, whatever it is. You have to know how to do that. So Henry wrote math video games for that. And in class, we had fun and we talked about difficult problems. And occasionally we spent time on the fundamentals of how you do these things, multiply polynomials, subtract decimals, whatever it is. But then all of the practice was done on the computer. So this made math class a lot of fun, and it made it one of the classes students really wanted to go to. We can't wait for Monday, Wednesday, and Friday. Tuesday, Thursday are bad days. There's no math class. We want the fun stuff. We want it to be math class. So it was great to teach in that environment. And even down to the grades below the ones where I taught, 7, 8 years old, we did things like, my colleagues, I didn't teach in those grades, Jeff did, and we would do things like function machine games. Here's draw a silly picture of a function machine that eats numbers and spits out other numbers, and you can probably guess how this works. We have some function, we don't tell them, they guess numbers, they put numbers in, they guess what comes out, eventually they get the idea, then we start making it tricky by putting in difficult numbers like large numbers or negative numbers, fractional numbers, according to the abilities of the students, of course. And so then we get to hone their mental arithmetic skills while playing guessing games. Okay, so that's what it was like to be a teacher at Black Pine Circle School. And eventually, somebody came up with the idea of putting on a math contest. So I imagine this is some vague analog to something that happened at Wits. So we decided, hey, we know how to do this. We have some mathematicians who are working as teachers here. They can write a contest. We can invite other local schools, have a contest day. Everybody comes in, takes the contest in the morning, and then our contest had 40 problems, so it was in 2 halves, one in the morning and then one in the late morning. Then we had a lunch break, and of course we were frantically grading during the lunch break, and then after lunch we reconvened and took turns leading discussions of the solutions. So we did a sort of a big, large group discussion where all of the solvers were welcome to weigh in. And in fact, we often learned something from them, because these were bright young kids, and they found ways to solve things that we didn't know. And occasionally they found solutions that contradicted ours, and we had to go back and figure out who was right and run back to the grading room and look through all the slips and change things. So it was a lot of fun. And so this was kind of a crazy, but not really crazy idea. It worked. We did it. We hosted these competitions for 8 years running. One of the crazier ideas was we felt like we didn't have to obey tradition. We could put in problems that we didn't know the answers to. We thought we knew the answers to, but we didn't exactly have a proof, right? So, and where did we get this idea? Martin Gardner used to write this very, very well-known mathematical recreations column for Scientific American. It was a monthly column in a print magazine, and it was just about puzzles. Sometimes they were mathematical, sometimes they were not so mathematical. And sometimes they were very, very tricky. Sometimes they weren't. Sometimes they were very open-ended. You could solve them in a number to various degrees in various ways, and sometimes he wasn't certain of the best answer. He just put the problem out there. He knew, a good answer, but maybe not the best one. So we put these on our exams, and so I'm going to tell you. So the last thing I want to tell you in this talk is the story of one such problem. Let me make a couple of quick comments about these competitions that we ran and so forth, and then I'll get to the problem. So one was we had great fun writing problems, hosting the competitions, so forth. And my only regret looking back is we didn't have more alternative events for those kids who weren't so fond of competition. Kids who wanted to do some cool math beyond what was in school, but didn't really like the competitive aspect, give them a stomachache. We didn't have anything for those kids. And nowadays we do much better at that. And it turns out you don't have to like competition to be a first-rate math student. Well, I'm talking to a bunch of competition folks, so maybe this isn't speaking to you so much, but I think it's important because there are many, for every kid who likes competition, there's one or two who don't. And then secondly, I would say many of the so-called crazy things that we did, they were radical, but actually pretty sane. And one of the I think putting problems that we didn't know the answer to on a competition was not one of those good ideas. If I had to do it over again, I probably wouldn't do that, just because it fails to teach something about mathematical rigor that perhaps should be taught. But we tried out a lot of zany ideas, and you have to try out good and bad ideas and see what happens. Anyway, it wasn't a disaster. So let me tell you about problem 27 from the late morning session of the 4th annual Black Pine Circle math competition. So here's the problem, and I don't really need a whiteboard. I can just say it. You have a cube, just a unit cube, sitting in space, and a bunch of other unit cubes. So of course they can't occupy the same space. And so your unit cube, you would like to place as many of the other cubes around it as possible, touching in a set of positive areas. So it has to touch face to face, right? If it just touches on an edge or on a corner, then that doesn't count. So so we want to nest these other cubes around it. Of course, they can't go inside it. They have to abut it, and they can't overlap each other. And you want to know how many of the other cubes, they're all unit cubes, how many of the other ones can you get simultaneously to touch the given cube, right? So that's the problem. And I asked John and Pravesh yesterday, I posed this problem. I said, I'm going to talk about this problem. And now I'm going to find out from John how many he thinks you can get.
Okay, so I got a lower bound, a construction which gets you 20. I've got a upper bound of 42, and I have a strong suspicion that the answer turns out to be 24. But I can't quite stick things in the right way. So let's see how wrong that is.
All right, let's see.
Right.
So, so let me share some pictures. Let's see, share screen. Let's see, it may take me a minute to say which one I want to share. Okay. All right. Well, I can't see if I've successfully done that. Yeah, okay, good. So this is a two-dimensional picture, which is a square. My square is the blue one. I drew it looking at it rotated by 45 degrees, but it should be the same size as the black squares. And this is a way that I could have, so imagine these, the black ones are cubes sitting on a table, and I'm looking from above, and I place the blue one on top of them in that way. So the blue one touches all 7 of the black ones shown. So perhaps, so given what Jonathan's lower bound is, I'm guessing he got the lower bound more or less this way. You sit this blue one on top of 7, and then another 7 can sit on top of the blue one, and then you sandwich it from above and below, and let's see what happens when you go around the 4 sides. On 2 alternate sides, you could obviously put 2 cubes so that they extend, beyond the edge. And then on the other 2, everything is sort of locked in, and you can only get 1 cube. So that is a nice lower bound of 20. Okay. So, by the way, as far as upper bounds, the reason we didn't know the answer to this problem when we put it on the competition is that we didn't have any non-trivial upper bounds. So for example, I don't think I knew, well, I think I probably knew how to prove 42. You can do it with a volume count. How many centers of cubes can there be, non-overlapping cubes, can there be in a region that can still reach to touch the inner cube? But, you expect 26 to be an upper bound, because that's what would happen if you were allowed to touch on edges and corners and you just packed it the way cubes normally pack. But we couldn't prove that. I still don't know how to prove that. And so, but there is some room for doubt. So we put this on the competition, and we thought that 20 was the best answer. And we got, in fact, the fact we didn't know the real answer didn't affect us too much, because nobody said anything greater than 20. So since we knew 20 to be a lower bound, the students who said 20 got the right answer, as far as we were concerned, and everybody else didn't. And what happens sometimes is if somebody brought another question, another solution to our attention, and in fact it was better, and it showed that the solution that we thought was the solution was wrong, often we allowed both answers to be, unless it was just a silly mistake, in which case only the new solution was right. But sometimes, in this case, had somebody presented a better one, we probably still would have given credit for the other one, as long as we really didn't know the better one at the time and had graded that. I don't know, we made on the spot decisions. Who knows what's the right thing to do? But let me show you that you can do better than 20. So now let me go share. Let's see, stop sharing this and start sharing another picture. So in this other picture, let's see, select. In this other picture, we again are going to put our cube on top of a bunch of other cubes. But this time, when we do that, let's see, there it is. This time, we're not going to go past the north boundary of our cube. So these other cubes, let's say, sitting on top of our cube, glued on top of our cube, they obviously won't balance this way. These other cubes can extend south, east, and west of the given cube, but not north of it. And so, in fact, we moved it back a small distance s from the north boundary. And instead of 7, the best we think we can do now is 5. But this, because of how we've done it, you can now put 5 around 4 sides. We can put it on this top edge of top face of the original cube, and then we can put it on the north face, and then the bottom face, and then the south face. And so we get 5, 5, 5, 5, and then of course the left and the right faces, those are just we can only stick 1 cube in each. So we get 5 plus 5 plus 5 plus 5 plus 1 plus 1. So that is 22. So, and to prove this, you know, you have to prove this picture is real. You have to prove that that there's a point that's within the black cube, or the top of that green square sits, such that if you choose that point and you make the angle at which the 5 sit with respect to the 1, if you make that the right thing, then and you slide the blocks around in such a way that all 5 of these really can touch the black one. So, okay, so you can get 22. So this problem actually came from a Martin Gardner column, and Martin Gardner published the solution 20 in his answers the next month. And so that's why we thought the answer was 20. But there was no proof, no upper bound to go with the construction. And in fact, a few months later, somebody wrote in with this 22, and no one had known that before. So okay, so 22. So everybody thought it was 22, and then Martin Gardner goes and a few months later receives another solution and publishes that, and this other solution has more than 22. So I won't go through the entire construction, but it starts like this. So this is a different way to get 7 on top. And this, so when we went from 7 to 5, we lost 2 cubes, but we gained being able to do it on 4 faces instead of 2. So that was wonderful. Now here, to go from 7 to, let's see, 1, 2, 3, 4, 5, 6, 7 again, you don't lose anything by doing it this way. And what you gain, as you can see, there's this vertical line, the western boundary of the distinguished cube, that you don't go past when you're above the midline, or sorry, when you're below the midline. So those 7 will fit like that. And if you do this on the top and the bottom, then instead of 2, 2, 1, and 1, you can do 1, 1, 2, and then the remaining face that's been opened up because these 7 don't extend, you can actually do 6. And if you want to see this for yourself, rather than have this devolve into a technical talk, I think you should go look this up. It's in an article by Martin Gardner in Scientific American, and you can go to your library and find it. I think it's December of 1971 it first appeared, or something like that, and I don't know what the follow-up is. Okay, so all right, so that's my math competition story. There's this crazy math problem. We didn't know what we were doing. We put the wrong answer in. We got away with it. Martin Gardner got away with it. There was a better answer. Then there was a better answer. I think still nobody knows. So 7 plus 7 plus 1 plus 1 plus 2 plus 6 comes out to 24. So I will have to find out from Jonathan later why he suspected the answer was 24. I don't know. And it seems to me likely that the answer is 24. But as far as I know, it's still open, and I don't know what the best upper bound is. So contest problems are fun. They make you think. They're not the be-all, end-all. But as you can see from some of the rest of my talk on my personal history, I think part of the be-all, end-all is to have fun while you're doing it. And I highly recommend teaching math as a fun activity. I know that makes me a little bit of a freak to think that when everybody else was, I don't know, going to concerts or something like that, what I did for kicks and my friends did was to become math teachers, very seriously trained to become math teachers. So, whatever floats your boat, but I do highly recommend it. And I think with that, I will pass it back to the MC for the next phase.
Thank you very much, Prof. Robin Pimentel. Absolutely fascinating window into the way that you guys think about these problems. And I do love the idea of the organizers sometimes not having the right answer. And that is very much what maths is all about, is throwing these things open to some of the brightest minds of the next generation and letting them really, really wrestle with them, which is very, very special indeed. I now pass on the conch, as it were, to Prof. Bessie Jonk. She's the former head of maths at Wits. She's one of the co-founders of this competition. She's a graph theorist, and she's going to be introducing our next speaker, a South African speaker, Prof. Willem Conradie. I'm hoping that Prof. Jonk is there. Prof, you need to switch on your microphone and your camera, and then we can see you. Absolutely fascinating window into the way that you guys think about. Okay, you definitely need to plug in the organizers sometimes not having the right answer, and that is very much what maths is all about, is throwing these things open to some of the brightest minds of the next generation and letting them really, really wrestle with them, which is very, very special indeed. I now pass.
So it looks like Prof. Jonk might be having technical difficulties. So I think I'm just going to apologize I'm going to introduce Prof. Conradie and apologize for not doing it as well as Prof. Jonk would. She prepared. Anyway, so Prof. Conradie is a professor of logic or professor of mathematics at Wits. His research area is logic. I believe he's assistant dean of teaching and learning in the Faculty of Science. And over to you, Prof. Conradie.
Thank you very much, Jonathan. Thanks. So let me just get my screen shared. I trust you can hear me. I assume if you can't, somebody will shout. Let's just share this window. So window, this one, share. All right. And then I'm going to move this thing over this side so I can see what's going on. So as Professor Pimentel already mentioned tonight, I mean, what you guys are doing is you are doing your competitions, and sometimes in school and undergrad mathematics, you do discover, in a sense, new mathematics that at least is new to you. But very often you realize that, well, somebody knew the answer before. So what I'd like to dispel tonight is a misconception that I certainly had as a high school learner, and even a few years into my undergraduate studies. Many people, and this is because of the way we encounter mathematics, have the idea that all mathematics has already been discovered. The Greeks worked on it. We know the ancient Babylonians, the Chinese, the Indians all made contributions to this, but it's sort of all ended with Newton, and we are just exploring this mathematics. That's what mathematical education is all about. Now, I'm sure many of you will know that that is certainly not the case, but I suspect some of you might have a similar idea, like I had as a high school learner. So lots of the mathematics that we learn at school is quite old, and I think this helps to perpetuate this misconception. So just to take a few of the big topics of high school mathematics. So geometry, for example, your Euclidean geometry, that is 2,350 years old already, long established, and in the works of Euclid. He was more a compiler of existing work rather than an innovator himself. So the algebra that we learn at high school. So one of the great innovators of this is Al-Khwarizmi, from where we get the word algorithm, who was active in around year 780, and further developments up to the 19th century. But high school algebra, more or less, you don't emerge from the 19th century doing high school algebra. Calculus, of course, founded in the 17th century, but by Isaac Newton and Leibniz. And of course, the clothes in which we see it today is slightly more modern, but essentially 17th century mathematics. Then if we look at a bit of linear algebra that you would get in your first year at university, for example, Gaussian elimination is already almost 2,000 years old. It goes back to, you can find the Gaussian elimination algorithm in Chinese mathematical texts of the year 179, for example. Systems of linear equations in the West sort of appear with Descartes' work in the 17th century as well. Matrices and their inverses, matrix multiplication, introduced in the mid-19th century, and modern sort of definitions of vector spaces introduced by Giuseppe Peano towards the end of the 19th century. So we spend a lot of time at school and at university, undergraduate at least, learning mathematics that in the sense is old, in a sense that it was discovered and developed a long time ago already. Now this, of course, is with good reason. Why do we spend so much time on learning such old material? So as you will know, mathematics is simply one of the oldest sciences in the world. People from all cultures and all over the world have been working on this for about 5,000 years, if you look at some of the oldest texts and engravings that are available to us. So on the left-hand side here, this is an engraving in a temple in India, and this is one of the first occurrences of the number 0. So that was one of the great contributions of the mathematics of the Indian subcontinent to mathematics as a whole, was the contribution of the number 0. So, and I think, in fact, I speak under correction, these little round bits that you see, these little circles, that is, in fact, the number 0 occurring there. It was sort of written more almost as a superscript. And as you will know, it's very difficult to do mathematics without the number 0, but for the longest time, at least in the West, we didn't have that. So mathematical knowledge is cumulative, of course. You need to know what went before in a certain field before you can go any further. So that is why we do spend a lot of time working on these really basic mathematical concepts and fields in high school mathematics and primary school mathematics and undergraduate university mathematics. The other important point to note is that mathematics is a deductive science. So unlike sciences like physics and biology, which of themselves are reasonably young disciplines, what we prove in mathematics remains true, because we're not trying to model the physical outside world. So any theory in physics or biology or chemistry is a model of certain phenomena in the physical world. And such a hallmark of a scientific theory is that it is subject to falsification. If we get better data, more data, a better theory which explains that aspect of reality better will replace an older theory. That is not something which happens in mathematics, because this is a deep philosophical question, but what we are essentially studying is our own thought processes, which have profound implications for the other sciences and for the way we perceive and understand the world. But mathematics, once something is proven, it's true forever. So the mathematical knowledge has this ability to grow over thousands of years, which we haven't seen in the other sciences. So this is why we need to spend so much time studying such mathematics. Now, where does so this is now, I've told you I'm dispelling this myth that all of the mathematics that is out there has already been discovered. A lot of mathematics is being added every day, new theorems being proven, new fields being opened up, and new questions being answered. And where do you find this? You find this mostly in journals, mathematical journals. So a journal is somewhat like a magazine in that it comes out monthly or twice a year or 4 times a year. And mathematicians submit their papers. These go through peer review. I'll talk a little bit more about that later. And if accepted, they get published in these journals. So typically you would find these journals in university and other academic libraries. So this is the Journal of the South African Mathematical Society. It's called Questiones Mathematicae. This was the volume 44, number 9 from 2021. So here are 2 of the top, the front pages of 2 of the top mathematical journals in the world, the Journal of the American Mathematical Society and the Journal Annals of Mathematics. So this is where the newest mathematics in the world appears regularly, where it is published. So there is a lot of new mathematics being produced, principally by mathematicians who are employed by universities and who teach and do their research in mathematics departments. And I want to give you a little, very small glimpse into this world tonight to tell you that, well, this is something that you might want to pursue as a career. You know, I'm sure that there are many careers open to you as young mathematicians. You can become actuaries, you can become quants, you can go into computer science, you can go into physics, as Simon pointed out. You can apply mathematics in so many spaces. But tonight I'd like to focus on what is it to be a research mathematician in an academic context. So, all right, so how much new mathematics is published every year? So I'm going to give you an extremely rough and probably very conservative estimate. So MathSciNet is a database which lists all the new publications, or most of the new mathematical publications every year. It's available online. And they currently list 1,800 journals. All right, so and in 2020, according to MathSciNet, if you search on all papers for 2020, there was 129,060 papers published. Those are the ones listed by MathSciNet. Now, different papers have different numbers of new theorems in them, but I took quite a conservative estimate and said, well, suppose there are 3 theorems per paper, then that means we get 387,180 new theorems every year. So this is more or less a constant if you look at the last few years. So that's an enormous number of new theorems published every year. There is no way that one person could even attempt to read all these theorems published in a year. So mathematics is expanding at an enormous pace, just like the other sciences. All right, so how does this happen? How this sort of the concrete process by which this happens. So mathematicians who want to do research or engage in their research would identify open problems or questions in the specific area that they research, that they are interested in. And then together with their collaborators and their postgraduate students, they would try to solve these questions. So typically one would try first adapting approaches that are worked in similar situations in your field or in related fields, or maybe the problem you're facing requires completely brand new approaches that you would need to come up with. So if you're successful in proving what you wanted to prove, maybe, or disproving what you wanted to disprove, then you would write this up as a paper. And then you can submit this to one of the many journals out there that I've mentioned to you. Now, once it gets to the journal, what happens then? So the editor of the journal will determine firstly the suitability of your paper. Is it suitable to the focus of the journal? Are the results interesting enough for the audience of readers of this journal? And if he or she judges it appropriate, they would then send this paper of yours, your collaborators, out to reviewers, 2 or 3 reviewers who are other people who are known to be experts in the field in which you have written your paper. So these reviewers, so you don't know who the reviewers are, so this anonymity of the reviewers is designed to allow them to give objective opinions, because if you know who they are, they might feel that they can't really give their objective opinion, and it opens the system up to possible abuses. So this is why this is anonymous. So the reviewers would read your paper, they would check all the correctness of the proofs, they would point out any errors, and they would write reports which would then go to the editor of the journal again, and they would list the strengths of your paper and the weaknesses of your paper, their opinion of it, any corrections, and based on that, so the editor might either accept your paper and say, we will publish it. If the reviews are that bad, they might just reject the paper, or, which very often happens, is that the paper requires some revision. You need to correct some things. There are certain things that they want you to, the reviewers would like you to explain better, and so on. And if you are successful in that process, maybe after resubmission, the paper is finally accepted, then the paper will be published in a forthcoming edition of the journal. And so you have added something to the mathematical knowledge of the world. You've written, you've proved these theorems, they have withstood peer review, they've been judged important and correct by peers in your fields, and so they therefore merit being published to the mathematical community in a journal. So now, of course, I mentioned to you that there are almost 400,000 new theorems on a very, very rough estimate being published every year. So this means that there's a lot of mathematics going on. And this is simply because mathematical fields are so diverse and there are so many people working on it. So the mathematical subject classification system, which is published by the American Mathematical Society, lists 64 broad areas of mathematical research. I'll show you a couple of them in a few minutes. Then it goes on for another 150 A4 pages to list all the subdivisions of these 64 broad areas. And a mathematician like myself, I typically work in a subdivision of a subdivision of a subdivision. There I specialize, and there I spend my life solving problems and publishing papers. So you shouldn't feel overwhelmed by the breadth and the amount of stuff being published, because specialization is the name of the game in the modern world, and you will focus on some particular area of interest to you in which you would receive training through your undergraduate and graduate studies. So so this is the URL where you can go and look up this subject classification of mathematics if you're interested in it. So I'm just going to list the first few. You will see history and biography, mathematical logic and foundations. So my speciality falls somewhere in the sub-classification of this. Combinatorics, order, lattices, many of these things you might never have heard of. There are many of them. It's quite interesting to go and have a look and explore this classification to get an idea of how big the world of mathematical research is and all the different fields that are out there. So when do you get to do research? So solving problems, participating in mathematics competitions, coming up with innovative solutions to problems, that already is a form of research. It's preparing you for the hard research of a research mathematician. So at university, Typically on undergraduate level, most undergraduates won't be engaging in research proper. But on the next slide, I will mention to you that it is not impossible for undergraduates to already engage in research. It's unusual, but definitely possible. So in South Africa, as you know, after our 3-year Bachelor of Science degree, we have 1 year of the so-called BSc Honours year, and that includes a big research project. You'll do a lot of courses there, but you will also do a research project. So you will work on a small problem over there. Typically, that's not something that is big enough to get published yet, but there are instances where people do actually very nice original research as part of their honours projects, and it does get published. So after the honours degree, you do a master's degree, a Master of Science, MSc, which typically takes 1 to 2 years. This would typically be research-based, and often, but not always, the research coming out of here would be publishable, typically together with your supervisor or people from their research group. And then the PhD, the Doctor of Philosophy, which takes between 2 and 4 years and comes after a master's degree. This, of course, is really research-based par excellence, and this must lead to publication. Here you are expected to make substantial contributions to your field, published in journals in order to qualify for the PhD degree. So that's the typical trajectory. And as an undergraduate, you can already get involved in research. As I said, this is unusual, but if you approach some of your lecturers and you can show that you're really interested and willing to go the extra mile and do a lot of extra work, then you can actually do publishable research. So here I list a few journals which are actually dedicated to, or some of them are completely dedicated, others dedicate some space to this, to the work of undergraduate researchers in mathematics. So if you want to go and look at what undergraduates who do research in mathematics get up to, go and explore some of these journals. There are also others. So I hope I gave you a little idea of one of the possibilities that you can pursue if you are interested in mathematics, namely that the career of a research mathematician, academic mathematician, and I certainly hope that some of you will be interested in pursuing that route. Thank you.
Hi, Simon, you're muted at the moment.
My apologies there. Thank you very, very much, Prof. Conradi. Thank you very, very much for that. And I love the idea of undergrads being able to contribute to the world of research mathematics, and the fact that you have dedicated journals to that is absolutely phenomenal and very, very forward-thinking as well. So I think that is wonderful advice to some of the folks who are watching us today. All right, we're going to move straight on to, I'd like to introduce Dr. Celeste Johnson. She's the founder of the Wits Maths Competition, and she completed her PhD in physics at Wits, and then has subsequently hosted a whole lot of conferences and workshops. She's been very, very involved in this whole process, and she will be presenting the first set of awards tonight. Prof. Celeste, thanks very much, or Dr. Celeste, rather, thanks very much for joining us.
Thank you so much, Simon. Yeah, wow, it's absolutely amazing. Such a privilege to have you present for us. Thank you so much. Thank you, Prof. Chetty, for taking the time to be here. Prof. Permansel, that was an absolutely invigorating discussion, and I think you're completely right. Maths teaching is definitely one of the most exciting things. And yeah, thank you so much, Prof. Conradi. I'm always in awe of the way you explain maths, and thank you for giving everybody a good explanation for how, you know, the whole research journey actually goes. So I think I'm going to be sharing my screen unless Pravesh tells me otherwise. Cool, can you see my screen there?
Okay, you're on the screen.
All right, can you see the whole screen? Sorry. Okay. All right. So once again, welcome to the prize giving. And we're going to start off with the schools in the middle primary section. So I think one of the exciting things about this year is that we've definitely had a far bigger reach, as Prof. Chetty mentioned. So we've had some schools from Mpumalanga, from the Western Cape. So welcome to all of those schools. And you'll see as we go along, there were some schools from Rwanda and Nigeria that won prizes. And I think this is just such an exciting thing, not only to build the Gauteng maths potential in the country, but the whole country and the whole of Africa. And, you know, we've got so much opportunity to do really cool things here. So let's start. So we've got a notable quintile 3 school, Watakong Primary in Mpumalanga, so congratulations. And then now you're going to see we've got a top 10 in Gauteng, and we've also got a top 10 in the entire competition. So in 10th place in Gauteng, we've got King David Victory Park Primary School, well done. Then in 9th place, we've got Kuro Helderbeek School. So that's in 9th place, well done. Then 10th overall and 8th in Gauteng, we've got King David Linksfield Primary School. And then 9th overall, and in 7th place in Gauteng, we've got Auckland Park Preparatory School, very good. Then in 6th place in Gauteng and 8th place overall, we've got Trinity House Rand Park Ridge. Then 7th place overall and in 5th place Gauteng, we've got Yeshiva College. Then in 6th place overall and 4th place Gauteng, we've got St. John's Preparatory School. So yeah, we've had a few more schools and a few more very good schools participating. So this is so exciting. We're definitely getting maths on the map here. Then in 5th place overall, 3rd place Gauteng, we've got Large School Tigerpoort. So very good, that's from Cape Town. Then in 4th place overall and 2nd in Gauteng, we've got King David Sanson. And now we're getting to the very exciting positions. So in 3rd place overall, we've got Crawford Preparatory in Lelucia. If I'm not mistaken, that's Durban, but, well, not Durban, somewhere on the coast over there in those warm suburbs. So as I say, it's so exciting to have a whole bunch of South African schools participating. Then in 2nd place overall and 1st place in Gauteng, we've got Red Hill Primary. And then 1st place, hailing from Cape Town, we've got Sweet Valley Primary School with an absolutely impeccable record. So congratulations, everybody.
Excellent. Thank you very, very much, Prof. Celeste, and congratulations to all of those kids who did so well in the junior echelons of this maths competition. And I'm so sorry we can't round you up for a round of applause, but just know that you can be very, very proud of yourselves indeed, and know that you've done well. And I hope that your headmaster and your teachers will praise you when you next get a chance to be at school assembly. I'm now going to call on one of our hosts this evening, Dr. Jonathan Karev. He is the project manager for the Wits Maths Competition. He's one of the co-founders of the competition. He's the principal organizer of this one. He did his honors, his undergrad and his honors at Wits, and then he went across and he did his PhD at the University of Pennsylvania. And this is something that I tell folks all the time. You don't need to do undergrad internationally. If you do a strong enough undergrad in South Africa, I promise you any international university will snap you up. He's returned to South Africa in 2014. He's been a postdoc fellow at the School of Stats and Actuarial Science at Wits, and he now works as a data scientist at Isazi Consulting. He does plenty of coaching of Olympiad. So, Dr. Karev, I'd like to welcome you, sir, and you can then introduce the next round of the awards.
Hi, everyone. So me again, and let's get into the. Just trying to find the right awards. Okay, upper primary. So first we have Botteking Public School as a notable quintile 3 school. So for those of you who don't know, the South African government has, JP High Preparatory, 10th overall, 9th in Gauteng. Law School Tygerport, tied for 10th overall and 9th in Gauteng. Okay, close fight. Yeshiva College, 9th overall and 8th in Gauteng. Trinity House, Rand Park Ridge, getting 7th in Gauteng and 8th overall as we progress up. King David Victory Park Primary School gets 7th overall and 6th place in Gauteng. St. John's Prep, 6th overall, 5th in Gauteng. Congrats, St. John's. Stain City School, I believe a new school this year, 5th overall and 4th in Gauteng. Welcome. Moving into our overall silver medal, St. Scythian's Boys Prep, 4th overall and 3rd in Gauteng. King David Linksfield Prep, 3rd overall, 2nd in Gauteng. And 1st in Gauteng, 2nd overall, Red Hill Primary. And in 1st place, once again, Sweet Valley. Congratulations, guys.
There we go. Fantastic, guys, and well done again to all of those schools. Lovely to see new schools like Stain City, so one of the brand new campuses. And just a quiet word to all of you out there. I know that they are free and easy with their scholarships. When I say that, I mean you've got to be good enough. But it's a brand new school that is very, very keen to attract talent. So always a good one to talk to. But well done to all of the other schools there. Absolutely superbly done. Let's now move on to Prof. Musamanzi, the director of the Wits Seismic Research Center. Can I say that his research is ground-shaking? Probably not. But he will be presenting the next round of awards, and I look forward to listening to Prof. Musa.
Okay, thank you very much, Simon. Again, thanks for hosting this. I'll be presenting the awards for the junior secondary schools. So as you can see there, the award for the school in a notable quintile 1, we've got Tokelo Secondary School. Well done to Tokelo. And then in 10th place in Gauteng, we've got Bellew College. Well done to Bellew College. In 9th place in Gauteng, we've got Yeshiva College. Well done to them as well. As you can see, the Parktown High School for Girls, they got 8th place in Gauteng. And then in 7th place in Gauteng, we've got Sri Bharat Shanda Mandar School. Well done to them as well. And then Trinity House Rand Park Ridge got 6th place in Gauteng. And then in 5th place in Gauteng, we've got Radial Heights School. 4th place, Gauteng, we've got King David. As you can see, they've been appearing almost all the years. Well done to King David. And then 10th place overall, we've got Hilton College. Well done to Hilton. And then 9th place overall, and 3rd place in Gauteng, we've got De La Salle Holy Cross College. Well done to them as well. 8th place overall, and they got 2nd in Gauteng. That's Cornwall Hill College. 7th place overall, we've got the Ambassadors College. And then 6th place overall, we've got Somerset College. 5th place overall, we've got Westerford High School. And then 4th place overall, we've got Bishop's Diocesan College. And then 4th place overall again, we've got Bishop's Diocesan College. Well done to them. And then 3rd place overall, we've got Graceland International. 2nd place overall, we've got Rondeport Boys High School. Well, 1st place, the big winner here in Gauteng, as well as 1st place overall, that's St. John's College. Well done to St. John's as well. Thank you so much.
Okay. Oh, yes, because she's yeah. Hi. Yeah, so I should have mentioned that the junior secondary prize is named after James Leridan, and we're just going to have Dr. Belinda Huntley say a few words about Prof. Leridan before we move on.
Good evening, all. So it's my pleasure to introduce the Professor Paul Leridan Prize. Professor Paul Leridan was recognized as AMISA's first honorary member for his outstanding contribution to maths education in South Africa. His contribution is characterized by its extent, its quality, and his utter commitment over 3 decades. There are no doubt many of your teachers who have been students of Prof. Leridan in one way or another. Students in schools experience his influence on the learning of maths every day as they use his textbook series, Classroom Mathematics. His complete and utter dedication to the field of maths education, from classroom practice to national policy development, is an inspiration to all educators. And this evening, I have the privilege to honor Professor Paul Leridan by presenting the Paul Leridan Prize for the Junior Secondary Awards, which Professor Manzi read out for the grades 8 to 9. Thank you.
Thank you very, very much, Prof. Huntley and or Dr. Huntley. I've had the privilege of chatting to Dr. Huntley extensively about maths education, and she is a mine of knowledge and of thought around particularly gender bias within maths education. And I think she is someone that if you're ever wondering whether or not you should get involved in teaching maths further on, please do get in contact with Doc Huntley. She is a phenomenal human being and a phenomenal academic. Okay, so I think that the next presenter is going to be Prof. Archibald. I know that the prize is going to be presented by Mr. Michael Fridjon. So I'm going to allow for a little bit of guidance here from the organizers, but otherwise we can move straight on to the awards for the secondary schools.
Secondary. Over to so next up is the Peter Fridjon Prize, which will be presented by Michael Fridjon. And take it away, Michael. Thank you.
So thank you very much for this opportunity to address the group this evening and to present the prize, which has been very kindly named after my late brother, Peter Fridjon, who was a professor and head of the Department of Statistics at Wits, certainly until his death or just before then in 2017. Peter was one of those extraordinary human beings who combined one of those photographic memories that you hear so much about, but very rarely see in practice, with an amazing sense of compassion and sense of education. He started his career in academics, having qualified at Wits and then overseas at Lancaster University, by spending several years teaching in secondary schools in the country. And that gave him great insights into both the study of mathematics and the difficulties of studying mathematics, insights which he took with him when he joined the staff of Wits University. And I've met many people over the years who had encountered Peter as students of his and found that his insights into what they were trying to understand and his insights as a teacher into how to help them to advance their own knowledge and understanding of maths and stats was unique. He was a gentle and generous human being. He died far too soon, but I think he made an enormous impact, not only in the study of mathematics and statistics, but also in the wider spirit of academia in South Africa. And it gives me great pleasure to be called upon to present this prize. Thank you all very much indeed for naming it after Peter. I'm going to now read these places, if that's what you wish me to do, Jonathan. And I'll advance as follows. The notable quintile school is the Sefaloko Secondary School, followed with Parktown High School for Girls, which was 10th place in Gauteng. Red Hill High School, 9th place in Gauteng. De La Salle, 8th place in Gauteng. The Yeshiva College, 7th place in Gauteng. The Sri Bharat Sharda Mandir School, 6th place, Gauteng. Beaulieu College, 5th place, Gauteng. Crawford College, Pretoria, 4th place in Gauteng. Bishop's Diocesan College, 10th place overall. King David Linksfield, 3rd place, Gauteng, and 9th place overall. St. Stithians Boys College, 2nd place, Gauteng, and 8th overall. Somerset College, 7th place overall. The Ambassadors College OTA, 6th place overall. The École de Sciences Biyimana, 5th place overall. Stellenberg High School, 4th place overall. Welkin International School, 3rd place overall. St. John's College, 1st place Gauteng and 2nd overall. And Graceland International, which comes in 1st place overall, an extraordinary and very broad achievement from a vast number of schools. Congratulations, everyone.
Thank you very, very much, Michael, and thank you so much for the wonderful tribute that you gave to your brother, Prof. Fredjon. I'll now call on one of our co-organizers, Pratish, who will be presenting the next round of awards.
Hey, everyone. So this award is for teams that have competed in the university section. So what we've allowed students to do here is to self-organize into teams that can then take part in the competition together instead of individually. In 4th place, we have a team called Kiss My Access from the University of Witwatersrand, and they've taken 4th place, and it's a great achievement. In 3rd place, also from Wits, we have a team called Divide and Conquer. Congratulations to Divide and Conquer. In 2nd place, from the Botswana Institute of Science and Technology, we have the Mathematicians. It's really good to see their performance as well. And in 1st place, we have a team from Stellenbosch called Somebody Once Told Me. So congratulations to you. Somebody Once Told Me.
Somebody once told me, come on, Pradeshi. So yeah, thank you very much to the university guys. And this is really, really important. When you get to university, to still have that fun with maths and to be involved in maths competitions is so fantastic. And that's where you learn and where you connect and where you make informal connections with guys that you might land up doing postdoc work with, in North America or Germany or China or wherever later on. It's really, really important that you get involved in those sort of things. I think now we're moving on to Dr. Kivan. I'm not 100% sure. There we go.
Hi, thank you. Sorry about that. So this is sort of an intermission to give thanks to all the people who've made this happen. Prof. Chetty already did a hell of a job of it, but I feel I should add my thanks to his. Should also mention that we have the university team competition, partly because we don't have enough universities to really make a meaningful top 10, and partly because we figured students would make up really interesting names, and they did. So if you're a student who's competing next year or 10 down the line, then you should definitely start thinking of awesome names now, and particularly punny ones. I'd like to thank the regional coordinators, firstly. We could not have this reach without them. I'd like to thank our sponsor, Sharp, and of course, Wits, who put this competition together. Prof. Chetty for speaking and for funding the competition. Robin and Willem for speaking to us today. We have formed an ethics committee to deal with cases of suspected cheating. That's Torrin Greenwood from North Dakota State University, Andrew Obis from CUNY, New York, and Liam Baker from Stellenbosch. We really can't do this without, all these people who are doing such a good job of chipping in. The setters, the teachers, and academics and veterans, everyone who's sat for hours and argued every question and argued that there were too many combinatorics questions or not enough geometry, or that this was too hard for this art in the paper or too easy for it. Just a huge thank you to everyone who did that. To Prof. Young, who organizes it, to Sel, Moose, and Pravesh. We really couldn't have this done without you. And so I guess those are my thanks. And we should now move on to the university winners. The individual winners. And I believe Prof. Archibald is going to read the winning middle primary students.
Okay, I hope you can hear me. I have the pleasure of congratulating individual people, so we actually know the names and not just the names of schools. This is the middle primary individual, and we just wanted to give good thanks and congratulations to all the people who took part, and particularly the following. The notable quintile 1 learner, the first one, is Andiswa Mbata from Sudumuka Primary, and also from the notable quintile 2 learner from Boitakong Primary is Molitsani Retabile. So we have a notable quintile 4 learner called Boikarabelo Mochadibane from Chedemosho Primary School. Congratulations to you. And then we start with the overall. So the 10th place overall in Gauteng is from Red Hill Primary, and it's Lihyang Lee. Also from Red Hill Primary in 9th place overall in Gauteng is Zhengshuang Liu. Then for the best proofs in Gauteng and the best proofs overall and 8th place, also from Red Hill Primary, is Aria Naran. Congratulations, that's 3 things to your name. And then 7th place overall at Smith Home School is Mayan Smith. So 6th place in Gauteng from King David Linksfield is Chase Cohen. And then from Red Hill Primary, which is appearing quite a lot of times here, congratulations to Red Hill. 5th place in Gauteng is Orion Fernando. So 10th place overall, FI's Maths Club, is Lara Maria. And then 4th place in Gauteng and 9th overall is Judah Leviton. 8th overall and 3rd in Gauteng, so that's the podium for Gauteng, is my namesake, Margaret van Zyl. And 2nd place in Gauteng and 7th overall, Hanro Basson from Bakken Academy. Then Auckland Park Prep, quite close to Wits, geographically speaking, was 1st place and top girl in Gauteng, and 6th overall is Sarah van Gotten Cohen. Musa Taleb from Taleb Homeschool was 5th place and best proofs overall. 4th place and best proofs overall from Phil's Maths Club is Adam Rosal. From Sweet Valley Primary, 3rd overall, so that's a podium for overall, is Holly Wormsley. Zoe Rightford, also from Sweet Valley Primary, was 2nd and the top girl overall. Congratulations to Zoe. And the 1st overall, also from Sweet Valley Primary, Finn Williams. Congratulations to everyone.
Thank you very, very much, Prof. Archibald. We're going to ask you to actually stay on and do the upper primary individual awards as well. And then we will move on to one of our named awards that comes afterwards.
Okay, that must be because I pronounced the name so well, right? Okay, here goes again. So, notable quintile 1 learner from Sudumuka, so this is the upper primary, is Nonkazimulo Masondo. Congratulations to you. And a classmate, or at least a schoolmate, also from Sudumuka Primary, is called Masipile Ntumbela. Congratulations to you too. Into the quintile 3 notable learner from Boitakong Primary School is Boitomelo Majake. And also from Boitakong Public School, notable quintile 3 learner. Try to say that quickly 5 times. Karabo Mawela. Congratulations to you. And we have a quintile 4 learner who is notable, Laseri Beloi from Chedimosho Primary School. Congratulations to you. All right, from Red Hill Primary, the best proofs in Gauteng, Kale Sigal. I look forward to marking your proofs in first year. Okay, best proofs in Gauteng, St. Stithians Boys Prep, Pravit Ramtahar. Congratulations to you. Okay, best proofs overall from Sweet Valley Primary School is Beth Hobden. Congratulations to you. Ruben Venter from Law School Garsfontein was 10th place in Gauteng. 9th place from St. John's Prep is Thomas Hall. King David Victory Park is making a presence here in the 8th place in Gauteng, and that is Aaron Dorfin. Okay, so we're up to 7th place in Gauteng from Red Hill Primary, Nicholas Schmidt. Louis Schumann from Homeschool Midrand was 6th place overall, 6th place in Gauteng, sorry. And then 10th overall in 5th place in Gauteng from Sacred Heart College Marist Observatory is Ziben Zhang. Sweet Valley Primary, making another mention, is Zach Buerter, who was 9th place and had the best proofs overall. Liam Baruch from Hersliya Primary was 8th overall. Yassine Dada from Wits Siankopa was 4th place in Gauteng and 7th overall. Minjiang Cheng from Red Hill Primary, 3rd place in Gauteng, bronze medal, and a podium, and then 6th overall. Congratulations. Enrile Victor from Hoërskool Hopetown is 5th overall. Fourth place overall, we're almost at the end. Sweet Valley Primary, we've got Luca Caranti. Congratulations, Luca. Noah Rosal is third place overall. You got a podium in the overall category. Sure, there's a lot here for Jessica Solomon. Okay, you were second place and best girl and best proofs in Gauteng, and second place and best girl overall. Congratulations. I don't think there's much more you could have done. All right. So Noah Greenblatt, first place and best proofs in Gauteng and first place overall. Congratulations to everyone. You've done really well.
Excellent. Thank you so much, Prof. Oshbold. And we now move on to the junior secretary individual. This is one that is in honor of Prof. John Knopmacher, and will be presented by his son Arnold Knopmacher. And I hope that he's here on the line with us. There we go. Arnold, take it away.
Thank you. I wonder what's happened to my camera here. There we go. That's better. So I'm presenting a prize in honor of my late father, John Knopmacher. He did his PhD in the 1960s in Manchester, England. And when he returned to South Africa in 1965, he and the head of the department were the only people who actually held PhD degrees. That's very different from the present time when to even get a basic job as a lecturer in the mathematics department, you have to first have done your PhD. John is maybe best known for several books that he wrote in mathematics, which were based on his own research. And he held a prestigious National Research Foundation A rating for most of his career. I should also mention that he served as the head of the maths department at Wits for a period of 9 years. And I guess that's all I have at the moment. Okay, so I should announce the junior secondary individual winner, and that's Zandile Nomabunga from Tokalelo Secondary, and this is the notable quintile 1 learner. Then we have Loveness Motal from Tokalolo Secondary as well, and also a notable quintile 1 learner. Then Luke Brickhill from St. John's College, 10th place Gauteng. Joshua Andrews, Cornwall Hill College, 9th place Gauteng. Liam Jong, St. John's College, 8th place Gauteng. Samuel Blow, King David Victory Park, 7th place Gauteng. Estienne Jordan, St. John's College, 6th place and best proofs Gauteng. Daniela Rubenson, King David Victory Park, 5th place Gauteng. Nicholas Delport, St. David's Marist College, 4th place Gauteng. Noakuna Faithful Chikamzo, Graceland International, 10th place overall. Aidan Leach, St. John's College, 3rd place Gauteng and 9th overall. Jonathan Schlesinger, Rondebosch Boys, and 8th place overall. Joel Krasner, Yeshiva College, 2nd place Gauteng and 7th overall. Yin Zhu, Red Hill High School, 1st place and top lady Gauteng, as well as 6th overall. Jana Rousseau, Ems Viet in this school, 5th overall. Simon Oosthuizen, Westerford High School, 4th place overall. So Ian Lee, Redham House, Durbanville, 3rd place and top lady overall. Yukyam Kim, Redham House, Durbanville, 2nd place and best proofs overall. And Uf Kwamon Jacob Unwana, Graceland International, 1st place and best proofs overall.
Hi, Simon. I think you're still muted.
There you go. Yes, I am still muted indeed. Thank you so much for to Prof. Knomacher for his introduction of the prize that is dedicated to his father. It means a lot, I know, and so thank you so much for that. I'm now going to be calling on Prof. Huntley, Dr. Huntley, to introduce our next speaker, or our next presenter, that is Prof. James Ridley, but he will be introduced by Belinda Huntley.
Okay. It is a privilege to be able to introduce Prof. James Ridley. James was born in Johannesburg and educated at St. John's College, Wits University and London University, where he completed his PhD. He taught in the maths department at Wits for over 30 years before retiring as chairman. I was incredibly lucky and privileged to be lectured by Professor Ridley in my undergraduate and my postgraduate studies at Wits. James served on the committee of the South African Maths Olympiad for 15 years, and he is still involved with them in an honorary capacity. He has helped the Wits Maths competition since it started by giving talks and conducting training sessions in the Wits Siankoba Maths Olympiad Training Centre. Good evening, Professor Ridley, and I hand over to you.
Good evening, Belinda. Thank you. Can you hear me? I hope you can hear me. And thank you very much for the introduction. And all I need to do is have the names so that I can make the presentation, please. The first person is in the notable quintile 3 learner is Matapelo Makloha from Sifulogo Secondary. Congratulations. Then 10th place in Gauteng is Yun Tan from St. John's College. In 9th place Gauteng is Jonathan Stagman, also from St. John's College. 8th place Gauteng, Christon Basson from Tux Siangoba. And then, St. John's College appears again. 7th place in Gauteng, Angus Clark from St. John's College. Then 6th place in Gauteng from St. David's Marist College, Mohammed Zedan Kasim. And 5th place Gauteng, again from Tux Siangoba, Michael Dreckmeyer. In 4th place in Gauteng, Leo Juan from Crawford College, Pretoria. In 3rd place and top lady, I'm glad to see these senior secondaries are ladies rather than girls. In top lady in Gauteng is Danielle Nell, again from Tux Siangoba. 2nd place in Gauteng, 10th overall, from Red Hill School, Carl van Rooyen. 9th overall, from the Ambassadors College, OTA, Nkemka Aka. 8th overall, from Cannons Creek Independent High School, Kerry Porrell. 7th place in Gauteng, from the Ambassadors College, Mufifolua Akinola. 6th place overall, from Rondebosch Boys, Andre Turin. 5th place overall from Paro Falais, Benjamin Klein. 4th place, best proofs and top girl. Oh, she's a girl, I'm afraid, but I think top lady overall. From Herschel Girls, they are girls, but I'm sure they're all young ladies. Juliette Roux. Then 1st place and best proofs in Gauteng, Third place and best proofs overall from St. Stithians Boys, Tyrone Carsey. Second overall from Graceland International, Charles D. David. And wait for it. First place, best proofs overall from South African College High School, Emmanuel Rousseau. Congratulations to everyone there.
Thank you very much, Prof. Ridley, and we're going to ask you to stay on and present the Peter Sonak Award for the undergrads, the individuals.
I'd first like to say a few words about Peter. And those of you who've got sharp eyes might have seen his name already on the screen, because when Willem Conradi displayed the front cover of Annals of Mathematics, you'll see Peter Sarnak is on the editorial board of that, perhaps absolutely one of the top journals in the world. Well, I had the privilege of teaching Peter Sarnak, and he was quite clearly the most brilliant student I ever had. And it was a pleasure to teach him and to be able to call myself a friend of his up to this day. After completing his honors at Wits, he went to Stanford University in California, where he completed his PhD under Paul Cohen, who was famous for having proved the independence of the continuum hypothesis and the axiom of choice. Incidentally, Peter has always been full of praise for the standard of the mathematical education he received at Wits, even compared with those at this very prestigious school, Stanford University, that he went to for his PhD. After he completed his PhD at Stanford, he went to the Courant Institute in New York, then returned to the teaching faculty at Stanford. But since 1995, he's been at Princeton University and the Institute of Advanced Study there, where he was an associate of Andrew Wiles, who proved Fermat's last theorem. Peter has received many awards, far too many to name individually, but one of the most significant is that he is one of the select band of Witsies to have been elected a Fellow of the Royal Society. And in addition, in 1929, he was awarded the Sylvester Medal by the Royal Society. So a wonderful person to have been able to know in the very early days of his mathematical career, and somebody for all of us to look up to and to hope to emulate in some small way in the future. So it's now my pleasure to present the awards, individual undergraduate awards. In 10th place in Gauteng, Albert Roux from Tukkies. In 9th place, Malwande Nkonyane from Wits. In 8th place in Gauteng, Matthijs Steinberg from Tukkies. In 7th place in Gauteng, Gabriel Diamond from Wits. 6th place in Gauteng, Sonali Baga from Tukkies. 5th place in Gauteng, Tsepang Malefane from Wits. 4th place in Gauteng, Mohammed Utman Mula from Wits. 2nd place in Gauteng, did we have a third? Simile Nchalinchali from Tukkies. 2nd place in Gauteng, Louis Nell from Tuks. 10th place overall, Kahu Mutupi from Botswana Institute of, I can't remember, UST. So it's nice to have someone from Botswana in the finalists. 10th place overall and equal also from BIUST, Pumulo Pilani. First in Gauteng, top lady in Gauteng, 9th overall, Ilse Bellingen from Tukkies. 8th place overall, top lady overall, Danielle Klein from Stellenbosch. 7th overall, Katsu Ubutsang from BIUST again. 6th overall, Richard M.A. Magambo from AIMS in Rwanda. Merveilleux, mon ami. 5th overall, Jean Duplessis from Stellenbosch. 4th overall and best proofs overall, Jean, or is it Jean, Wright from Stellenbosch. 3rd overall, Emile Trudeau from Phil's Maths Club, which is a very interesting group that I didn't know about and which has done so very well. 2nd overall, Timothy Schlesinger, also from Phil's Maths Club. And 1st overall, also from Stellenbosch, and which has done amazingly well, Ralph McDougall. Congratulations to you all for a magnificent achievement. Thank you.
Thank you very, very much, Prof, and well done to all of those prize winners. And we are just going to pass on to Prof. Celeste, Dr. Celeste Johnson, who is the founder of the Wits Maths Competition. I hope. There we go. There is Prof. Celeste. She will hand on to Jonathan, and then we will close for the evening. Thank you very, very much.
Jonathan.
Hey, so thanks everyone who presented. Preferably when Peter talked about his good experiences at Wits, he normally talked about you in particular. Not that Wits isn't still awesome, but that is what he put the focus on. We have 2 special awards to our social media team, Kitumitsu Sebekwane and Sinuba Uyudada, who have really been a huge help. They set up an Instagram account, they set up a Facebook account. Congratulations, thank you so much. We could not do this without you. It's also probably a very good time to thank Simon here for this evening and for emceeing for us. It's really been an honor to have you. Thank you so much. Congrats to all the winners. I'm sure you guys have heard a lot of that tonight, but really well done. And it's for those of you who are new, welcome to the mathematical community. For those of you who are repeat winners, congrats again. Chat soon. And I'll just hand over to Sal to finish.
Yes, I just wanted to say thank you so much, John. You've got the most remarkable way of bringing people together, of collaborating. And yeah, I just think you've done a really, really stunning job of this. It's so exciting that this is the 4th year of the Wits Maths competition. You know, one of the fantastic things about this competition is that kids from grade 4 onwards are already getting into their proofs. I mean, just seeing Noah Greenblatt and, you know, Jessica and everybody else, of course, but like kids that we have literally grown from grassroots level who might never have known that they had such a talent. I mean, I can see them, you know, participating, you know, in the IMO one of these days, representing Gauteng. And, you know, thank you, Phil, for also helping, you know, train as Gauteng is as well. So it's just so exciting to see all the collaboration and the networking between everybody. Yeah, and congrats once again to the prize winners. And, you know, yeah, thank you all the schools who have participated, who have sent your learners in. And I'm just so excited that everybody's getting a passion for maths. And I think the way that Prof. Pimansel actually showed his enthusiasm for the subject and just teaching it, it really is, I think it's often far more fun than going to clubs and things like that. But, you know, those are my words. Anyway, so thank you very much.